Hello, today we're going to be talking about the design of a state transitioning robotic system using Arduino. This project was created for the purpose of competing within a competition for my mechatronics class. For this project, I had to design a robot that could be started when a light was turned on in the room. It could navigate a play field autonomously for 1 minute, and it can be controlled remotely for at least 30 seconds with either a autonomous or a teleoperation control after that 30 seconds for an additional 30 seconds. I decided to use an ultrasonic sensor for the purposes of running my robot. Because the playfield was a particular shape and its layout remained mostly the same, changes were due to slight errors in the placement of field objects. I decided that this would be the simplest way to control the robot, as the movements should be relatively predictable and repeatable. I also decided to focus on the white balls outlined in red on the playfield. Alright, so the conceptual design of the robot, I decided on a couple of parameters as well as those original criteria given to me by my professor. I wanted my robot to minimize its size. Obviously had to include some kind of light sensor in the design. I already decided that I was going to navigate using an ultrasonic sensor. Bluetooth module had to be added so that it could run via teleoperation. I wanted to use some kind of 3D printed manipulator to control pieces on the playfield, and I wanted to minimize the robot's weight. I have some analysis there. You can figure out the size by figure out the volume of a cube. That should be proportional to the, not proportional, but should give you an approximation of the size of your robot. The light reading had to, of course, be whatever the output was from the light sensor. The distance could be calculated using the duration of a pulse. See, the way that ultrasonic sensors work is they send out a little ping, and it comes back, and the ultrasonic sensor takes that in and registers it. I had to calculate the speed of sound in air, and then of course I divided that number by 2 because in reality the object was only 1 ping away instead of back and forth. Of course, for the Bluetooth module, it was just simply whether it was connected or not. The 3D printing part, I wanted to maximize the length while minimizing the height. Within a certain threshold, of course, because the manipulator had to be low enough such that it could control the balls and the cubes. It had to be long enough that it can control the cubes and the balls, but it couldn't be low enough that it couldn't get onto the balancing stone. Of course, I wanted to minimize the robot's weight. I decided for that to get it under 5 pounds. References there, if anyone's interested. Risk, for the size, the robot may overextend the boundaries of its container. Of course, that could be solved by just measuring it. Light sensor, well, suppose I'm in a different room. That's easy to solve. I just have to calibrate it to whatever the light reading in the room is. For the ultrasonic sensor, perhaps the module could detect some kind of reading while the lights are off, which would cause it to run, which would not be good. So the code had to be created in such a way that the ultrasonics would work only when a certain light reading was given. The Bluetooth module, easily disconnected from the circuit. I solved that problem by securing the wires to the Bluetooth module via a paper clip. 3D printing can easily go over budget. We were given a budget of $25 in additional materials. Of course, PLA is a extremely low-cost 3D printing material, so that's what I decided to use, as the stresses put on the piece wouldn't overdo what the part that I created could handle, and that the PLA could handle. Minimizing the robot's weight. Extensive use of parts could make the robot too heavy, so I used lightweight materials, for example PLA, and I minimized the amount of material on the robot. From here we go to a more detailed design. Light and sound. There's circuit diagrams here for each of those subsystems on my robot. Like I said, for example, light and sound is controlled by my ultrasonic sensor, as you can see, and this should also work in tandem with my light sensor, such that when the light sensor detects a certain threshold, then it says, okay, ultrasonic sensor, you can run and decide which way the robot goes. The Bluetooth module, well, that's just hooking up the Bluetooth module and saying what pins are the receiver and the transceiver. Motor control, I just used 2 servos for this project. Figured it'd be the easiest way to get the robot to move around the playfield. That's just hooking those up to certain pins, giving them a particular value of what to run at, and of course hooking up power and ground. From there, we go to the final design control of autonomous and teleop functions. There's flowcharts there dictating how the autonomous and overall general operation of the robot would work. This would be, or as you can see, the first one is the overall design, start, and then after that we say, okay, is the light above a certain amount? Yes. Okay, cool. Run the autonomous function. Wait. Then we can go to the teleop. For the next section, this is just how the autonomous would work. Is the distance less than 6 centimeters? Yes. Okay, go forward. No. Backwards. Turn right. And it will keep doing that until it finds an open spot, and then it can turn. Final design. I put a significant bit of work into the creation of the manipulator, as it was one of the most important parts on the robot. I decided to go with this particular design because I determined that it would not only would it be able to wrap around the cubes, it would also be able to push the balls. And the reason I put those little pins on there is to help it make contact with the balls, and the cubes are made of foam, so it could help stick to them a little better. The code is structured in if-then format. It's divided into several functions. These control the setup, autonomous driving, autonomous avoidance, and Bluetooth teleoperation. And as you can see, below that is a picture of the final robot design. Now, in terms of reflection, the project taught me a couple of things. The first of these is don't be afraid to do something different than everyone else. A lot of the robots use just an ultrasonic sensor for their operation, and this heavily constrained a lot of us, as it's hard to navigate by just determining the distance. It's like trying to, yeah, it's like trying to find your way around a room by just like tapping on a wall. Strategically speaking, it would have been more beneficial to use multiple sensor inputs. So if these were working in tandem, more complex maneuvers could have been done by the robots. Also, I don't know if wheels were necessarily the best idea. Perhaps some kind of walking mechanism could have helped a little better, or maybe even like a drone. I mean, there's nothing in the rules saying that you couldn't do it, so got to make the most of it, right? All right, thank you very much for listening to my presentation, and I bid you adieu.